Okay, everyone. This third installment of SST and modeling some of the problems that we were working through in class by hand. The next thing to do is to model this plate. So it's a 1 meter by 1 meter plate, two-dimensional plate. And I've created one here that is, I'll just go back here for a second. I've created a plate that is total 20 millimeters in thickness, and then it's symmetrical about the z equals 0, the xy plane, basically. Okay, so I've created that. And let's assume again with this scenario that, okay, this is the design department has created this plate, spent lots of hours creating this geometry, and now we have to, as the thermal analysts, we have to go ahead and design it. Now, we're going to follow the problem that we worked on in class, which was this one, I believe. Yes, we've got a plate 1 by 1, 1 meter in X and 1 meter in Y. We have at the X equals 0 vertical part of the plate, we have it's insulated. That is the slope at X equals 0 is 0. And then it's also insulated on the X equals 1 vertical line, also insulated. Then on the bottom edge, so that is Y equals 0 line, the temperature on that edge is 0. And then on the Y equals 1 line, we have this temperature distribution being maintained that looks like this. We have 1 degree for a third, yes, a third of the beam, and then 0, it steps down to 0 immediately. Okay, so this is our, these are our boundary conditions for the plate that we're doing. So let's go ahead and design this. So again, we're going to set up our own, in order to realize those boundary conditions, we're going to split our idealized part at this X equals 1/3 section. So that allows us to exactly model that in our plate. So let's go ahead and do that. So we're going to start application, pre-post. And let's create an idealized part as we did before. So it'll be plate idealized 1. Okay, in the correct directory here. Okay, so here I am in the idealized part, and that's taking a copy of the plate. So the first thing we do, as we did before, let's actually go down here into the part navigator. We're going to link in this plate geometry. So if the design department changes the size of the plate or the thickness of the plate, then we can go ahead and remesh. Okay, so let's change that. Okay, so you see here in our history, we've linked the bond. Okay, so as I mentioned, we're going to split the body, and which is our linked in body here. And we're going to split it at X equals 1/3. So that means we're going to choose the, sorry, I went too far back. Do we choose here? Yes, we want the YZ plane, and we want the one, oh, look at that, it's already at 333. Okay, so 333 along the X direction. So click OK to that. Okay, so it's going to split this body, and there we go. Okay, perfect. So the other thing we're going to do is, as we did before, remember we had this beam and we meshed along the center line. This time for our two-dimensional medium, we're going to use a mid surface. So there's a tool all ready to go for this. So we choose the mid surface here, and we're going to choose both of the split bodies now. Okay, and we've chosen the top and bottom faces, as it turns out. And I think all I need to do, I could do the manual. Sometimes you have to manually select the faces to be paired, but I think here we're good to go. So let's just let's look at the result. And we should be seeing, yeah, it's generated a plane for us. So let's take that. And there we go. Okay, now let's go ahead and so we hit Control W here, and let's hide the solid bodies. And yes, we have our center. So we can, if I zoom in here, we have this plane. It's right in exactly the XY plane. So that's perfect. Okay, so we're ready to go ahead and mesh this. So let's save this as our idealized part. And now we're ready to create a new FEM in simulation as we did before. Okay, and already it's clued in on our idealized part. Let's make sure we're incorporating definitely the planes and so forth this plane here that we created. And again, making sure space systems, Simcenter 3D, space system thermal. Okay, so we click OK to that. And let's create a solution. But let's do the meshing first, so we'll come back later and straighten that. Okay, so here we are. Now we're at the FEM. Now this time, remember before for the beam we used the 1D mesh. Here we're going to create two-dimensional elements or 2D mesh. So we click on the 2D mesh. Okay, and let's call this line plate, something like this. And we're going to choose the two surfaces that form that single plate. Let's choose, say, an element of length 33 millimeters so that we get a nice looking mesh at 333. Okay, let's not use any. Sorry, I want to have 0 triangles. Wait a minute. I want to turn to, yes, we want 0 triangles in this mesh. Okay, and there's another one here. Yes, we want to merge edges. So remember in the last model where we had the 3 segments of the beam, and where each of the segments met, we wanted the nodes to be merged at that spot. Well, here we have an entire edge, so we're going to merge the edges and match the edges. So I've checked off both of these options here. Okay. Okay. Yes, and same thing as before. We're going to create a collector here. Okay, so the first thing, material. Oh, yes, the type is thin shell. That's what we want, yes. Then we're going to create our own material. Let's create our new material. Again, we'll use aluminum properties here. When it comes back, there we go. And again, making sure we have the right units and numbers. Here. Then for the thermal tab, we fill in conductivity and make sure the units are correct. And then the units for that are correct. So we click OK. And so there's our aluminum. That's selected. That's good. Now here we can model materials that are not isotropic. But in our case, it is isotropic, so not a problem. Here, the thin shell, we're going to create a thickness. So remember, with the beam, we need to create the cross section. Here, for a two-dimensional element, we just need to supply the thickness. And here, the thickness was 20 millimeters. Okay, again, we're going to have no radiation for this problem. And then our name, let's call it rate. And there we go. Okay, so we're back to our 2D mesh. Let's see what this is going to look like. And that looks pretty good. Okay, so let's take that. Okay, so if we go back to our FEM navigator, remember we have our idealized part here that's been formed into polygon geometry. So we have the two surfaces, two plates. Now we have a 2D collector. Okay, we can run that check just to make sure. So let's do duplicate nodes. And let's run a check on that. And in fact, none of the nodes are duplicates. Perfect. Okay, let's go ahead and save that. And now we're ready to supply our boundary conditions. Now it's reversed up. Okay. There we go. Okay. So in this case, we only have constraints. Okay, so remember on this left side, so the x equals 0 line and the x equals 1 line, we have insulated boundaries. So we actually don't set anything there. And if there's no elements joining this edge, then there's no heat transfer. So we don't have to worry about that for the case of insulated. But we do have to set these other ones. So remember the constraint, let's do temperature constraint for the bottom here. And we're going to choose this bottom edge of both of those surfaces. Okay, so that means if we remesh, it doesn't matter. It will still make all of these elements associated with that edge 0 degrees C. Okay, so we click on that. And let's name this one. So let's edit and make this the bottom edge. Okay. And then we're going to do the constraints. Let's do a new constraint. Oh, so by the way, I'm doing a right click here when I go to constraint, new constraint. That's a left click, then temperature. So this time I'm going to choose just this edge here, and that's going to be 0. We'll give this the name top edge right, and that's 0 degrees. And then let's do the final constraint, right click, new constraint, left click on temperature. And let's do top edge left. Let's choose that edge of the plate, and that's the 1 degree of room temperature. Temperature of 1 degree. Okay, so we put that. All right, and here this is simple enough. There are no heat loads on the edge or on the outside. Everything is okay. Let's now edit our solution. Steady state, that's great. Nothing else is set here, so that's good. It's all ready to go. The only other thing was the parameter, the convergence. So in this solution will stop iterating until, or will stop iterating when the heat in and the heat out is calculated and they agree with each other to within 1%. Okay. All right, let's go ahead and solve. Let's get rid of these windows and then go here and load the results. And do the plot. Okay, so by now that's a familiar plot. Okay, so the 1 degree and then 0 here and then 0 along this edge. And then you'll notice as these colors approach this edge here, there's no drop of the temperature. So it's insulated here. Okay, so there's that one. And so let's save that. Now, the other more really fairly powerful feature of NX is this ability to create between surfaces that are actually not touching, we can still create thermal conductances between different bodies. And so this is a very powerful technique. And it's, if I move these surfaces, which I'll demonstrate, then we can just simply rerun the analysis and it can be repeated for different locations. So let's go ahead and see that in action. So let's go back here. So let's go back to our plate. And again, in our design department, we'll probably make this an assembly, but let's just keep things simple here and we'll create so let's go back to application and modeling. Okay, so we further, I guess, refine our analysis here. We add a second datum plane. and it'll be the XY plane, but let's make it, yeah, let's say 25 millimeters above the 0 plane here. Okay. And then we're going to create an extrusion, and we're going to sketch some curves on this new plane that we created. Okay, and let's kind of zoom out here. So we're going to create a couple of rectangles. Let's create one here, here, and then let's create a second one here, and here, like so. And close. Okay, let's actually dimension those. So let's zoom in here. Yeah, that looks good. 60 millimeters by, what's this one? 60 millimeters. Yeah, okay, let's make that square. So that's fine. This other one here, let's, oops. So I guess I didn't finish that dimension. Let's go back. Here. Okay, 60. So, okay, now let's do this one. 100 millimeters looks good. Let's make this one 150. So, just for variety here. Okay, and then let's also dimension their placement. So, relative to this edge, to here, let's make this it's 60. Okay, so let's make it 300. That way it straddles that edge that we created. And then from this edge to here, let's create another dimension. Let's make that 300. Okay. And let's do the same thing for this guy. Let's make it 700, let's say. And then drop this bottom edge. Here. Let's make it 650. Okay. So let's hit finish. And we're going to start here. Let's make these only 5 tall. Okay, so let me leave this video at this point, and I'll show the final analysis in a second. Okay, thanks for listening.